Here's another example of efficiency using rational functions. We're going to compare these two fields. Farmer wants to fence in the field shown. So this is one field, this is another one. And we're going to write a simplified rational expression for the ratio of perimeter to area. So we need to be thinking about how do you calculate perimeter? It's the sum of the distance around. So it's the total distance around, and then how do you calculate area? And we're going to have to get creative with this one, but I think we can figure that out. So over here, we've got a perimeter, which is really just 2x plus 2x plus 2x plus 2x, right? So that's 8x, I think. And then an area of length times width, so 2x times 2x, which is 4x squared. So the ratio of perimeter to area is pretty simple. We've got 8x over 4x squared. Let's simplify that. It's like simplifying an expression with a exponent in it. This x cancels out. The 4 and the 8 cancel with each other to leave a 2 on top. What do we end up with on bottom? Just an x, because x over x squared would be 1 over x. So this becomes 2 over x. So there's the ratio of perimeter to area for that first field. For the second field, perimeter is, again, the total distance around. So we're going to add all these up. I don't have a dimension on this side, so let's think about this. If that were parallel to this, this is x, and this is x. So now I think I can figure that out. The perimeter is, let's just start at the bottom, 3x plus x. Ooh, how far is this right here? Well, that's x right there. So, and the whole thing is 3x, so this has got to be 2x. So let's start that again. 3x for that whole bottom side, plus x plus 2x plus x plus x plus 2x. And I got the bottom. So all together, I think that's 10x. Okay. And then area, I think we're going to have to do this in parts. Let's just do this rectangle right here on the bottom. It's got a length of 3x and a width, we could say, of x. And then that leaves us with this square up here, and it's got a length of x and another length of x. So altogether, that's 3x squared plus 1x squared, 4x squared. And then we're going to do that ratio because we're basically looking for a fencing cost per unit of area. So we've got 10x over 4x squared. Let's simplify this. 10 and 4 have a common factor, which is 2. 10 divided by 2 is 5. 4 divided by 2 is 4. And x and x squared have a common factor, which is x. So we can cancel out the x there and cancel out the exponent there. So I have a 5 only on top, and I have a 2 x to the first on the bottom. Okay, look at those two ratios. Perimeter to area, 2 over x. So the cost per unit of area is let's say it's dollars, $2 per unit of area. Okay, and this one, how do we think about that? It's actually, you could write it as 2.5 because 5 divided by 2 is 2.5 over x. You could write it like that. So which one is a higher cost? 2 over x or 2.5 over x? Well, obviously this one. So that answers this other question. Which of the fields has the lower fencing cost per unit of area? This one. Lower cost per unit of area. Okay.